Hello everybody, welcome back where we are finishing our calcium part. Now we will move to the next element, the alkaline earth element we call is the barium, because barium is also very much useful industrially. Large number of compounds are well known what we produce from those barium salts and the barium ores and the minerals. So, we will only go for some useful compounds only. That is why it gives us a very good idea that what are the elements starting from the whole entire periodic table, the metallic part and the non-metallic part, what we can think of industrially and which can be useful industrially, and historically also how the journey has been started earlier for the getting some useful compound from these particular elements. So, we get the barite. So, barite is your barium sulphate. So, barite is your barium sulphate, which is known also as the heavy spar thing. Earlier we know that one is we also consider as the acid spar and other thing. So, it is basically used as a raw material for the manufacture of barium and its compounds. So, any barium compound, if you think of any barium salt, basically sometimes we can make some huge organic molecule also as its barium salt. When we do not go for its corresponding sodium salt or the potassium salt, we go for it as its barium salt. So, first we see that how we apply all these barium sulphate. So, this barium sulphate is basically the entire amount, almost the entire amount of that production, the 90% is utilized for crude oil and natural gas extraction. So, this is the most useful inorganic compound which is utilized in the oil sector, because the mud we handle, the drilling process we handle, there people use this particular barium sulphate for both oil extraction as well as gas extraction. And out of this only 5% is being used as the filler for glass manufacturing. Glass, we all know that it is the corresponding silicate material. So, you have sodium silicate material, then we add boron sometimes to improve its quality. To get the borosilicate glasses, now we can get little bit of barium salts also. So, these are all additives. So, these additives basically can give rise to the improved structure of the glass material. So, that is why some amount of barium can be utilized for making of glass, then rest the remaining 5% is manufactured for making useful barium based compounds or barium chemicals. And what are those barium chemicals which are industrially important, because industrially important compounds we basically produce in a large scale. Huge amount of some of these materials will produce. One is barium carbonate, next is your barium chloride, then synthetic barium sulphate, which we are not getting from heavy spar process for the heavy spar material, then barium sulphide and barium hydroxides. All of them have very useful applications. And the metallic barium, if we want to have it, earlier people make it industrially also, it is available for making television tubes, because it is used as a material for making of your vacuum tubes. The first compound what we can think of and what we can understand over here is your barium carbonate, and that barium carbonate what we get from here is the most important compound of barium after barium sulphate. So, after barium sulphate, the next compound what we can think is your barium carbonate, and how we make that particular compound is from barium sulphate, because it is readily available as heavy spar. Is first it is crushed, we make the powder. Before powder, it is after crushing we pulverized it, and it is almost powder formed, and then carbon is utilized as coke, that is utilized for the reduction process. So, barium sulphate gives you the reduction with carbon to give you barium sulphide, because the reverse process sometimes we can think of is also a very useful question to be asked to anybody, is that if you have a sulfur in your organic molecule or any other molecule, how we can estimate that amount of sulfur present in your material. So, best way of doing that thing is the reverse process. That means, sulfur we all know that there are systems where this can be very easily oxidized to sulphate, and that sulphate, whether it is a organic sulphate like your some long surfactant molecules earlier we have seen, or some inorganic sulphate material, that can be removed as sulphate anion, and that sulphate anion can be trapped as barium sulphate, because it is a very useful molecule and insoluble molecule, and you take it as the amount of barium sulphate which can be available from your sulfur bearing compounds. So, the same thing, that means that now we use as a reduction. So, reduction by carbon reduction, we get that particular barium sulphate, then barium sulphate is reacted with sodium carbonate, because our goal is to make barium carbonate, and we precipitate out it as your barium carbonate. So, we can handle three basically industrially important chemical reactions in large scale, because huge scale reaction or large scale reaction can be utilized over here for the first one, for the second one, as well as for the third one. So, first step immediately gives you barium sulphide through carbon reduction, and that barium sulphide is converted to barium carbonate by two different processes. One is by utilization of gas molecule carbon dioxide. So, you pass gas basically in presence of water, basically you are supplying carbonic acid. So, mixture of these two can give you the corresponding conversion of sulphide to carbonate, or in other case you add sodium carbonate, where the process of making that thing will be costlier, because sodium carbonate you have to identify that also as a separate material, and it has also some price. But carbon monoxide is a very cheap material and water is also readily available. So, the first reaction, that means the reaction of BAS with CO2 and H2O, what you get is a very cheap one, and where you can trap basically the carbon dioxide, whether it is the industrial effluent gas, or it is available from some exhaust, or it is available from the environment. Only thing that it should be highly concentrated one, because in the environment we do not have that much carbon dioxide which can be easily converted to your barium carbonate through the use of barium sulphide. So, we should know that particular process, because the carbonate formation from carbon dioxide is well known, and in strongly alkaline medium like sodium hydroxide we use it, and that sodium hydroxide can trap, or calcium hydroxide can trap your carbon dioxide to convert it to sodium carbonate or calcium carbonate. But making this carbonate directly from sulphide sample is a unique one, because by doing so you will be producing in the first case hydrogen sulphide gas, or in the second case sodium sulphide. So, in the second case may not be so expensive if you use also sodium carbonate, because sodium carbonate we all know is a very cheap material. So, that cheap material can be used for making of barium carbonate, which is a costlier one, because your barium sulphide is a cheap one, cheap material, because it has been obtained from barium sulphate. It can be converted to barium carbonate, which is a costly material, as well as your sodium sulphide, which has also some price. Then the process what we can think of. So, you start from the ore, you have the barite ore. So, you have to take that particular ore and you crush it. So, this is basically the whatever I told just now is your block diagram presentation. So, block diagram presentation will tell you and move you from your ore to your thermal reduction step by the addition of coke. You add coke, you go for the thermal reduction, and by that time you go for the grinding and pulverizing also. And while you go for both grinding and leaching, you get the barium sulphide solution, that means the reduction is completed, and is a continuous counter current decantation. That means you against the flow you decant something, and the decantation from the barium sulphide solution you remove the other part. So, removal of one part is your ore residue, the unreacted ore basically. So, you have this, that means the barium sulphide in solution. So, basically whatever thing was there from the sulphate material, you converted it to sulphide, and that sulphide is in aqueous medium. So, you can remove that particular one through decantation, because the liquid material you can transfer to some other reaction vessel, and your ore will remain over there, and the residual ore can be reutilized for this particular process. Then we have to go for the precipitation from the solution of barium sulphide. You add sodium carbonate by water and water. So, this is the second process what we are utilizing. Then we go for the drying process of the material and then sizing, that means the different sizes of the shapes, and whether you get the lumps, whether you get the some ball type of thing or the blocks. So, you get the barium carbonate as your product starting from your ore. This barium carbonate is very useful in manufacturing the clay based tiles and ceramic products, ceramic pottery to any other thing. So, some amount of barium is there. Barium is basically improving the material quality, the thermal resistance and its longevity. So, that is why some recommended amount is added during the manufacture of these clay tiles and ceramic products. Then the sulphide one, just now we have discussed how we get this sulphide and how we make this particular sulphide for this particular production. So, it is used in the manufacture of lithophone, that we all know that when mixed with zinc sulphide is for the painting purpose also. So, it is basically a co-precipitated mixture of that particular thing what we get from sulphide, that means barium sulphate plus zinc sulphide, H2S for making of H2S and for the synthetic barium sulphate through oxidation. So, synthetic barium sulphate, because the ore is giving you the natural sulphate. So, that is why we call it as barium sulphate. So, ore is also a barium sulphate material, your barite ore is your barium sulphate material. So, synthetic barium sulphate, when you manufacture it, when you prepare it in the industry, its purity will be higher. So, you take the barium sulphide solution and again like that of your addition of sodium carbonate, now you add sodium sulphate. So, is basically a metathetic reaction, and that metathetic reaction is not a double metathetic reaction, but it is addition of this thing. That means, barium is converting to barium sulphate and sodium is producing your sodium sulphide. So, our ultimate goal is to making of this barium sulphate, but at the same time you will be also producing sodium sulphide. And this formed barium sulphate, what we prepare is used as a filler, as a white pigment, that just now I told you that lithophone is well known white pigment. We use it as for painting purpose also. Then we use this as the contrast agent in medicine, because we know that sometime we go for the X-ray for our body, for our inside body. So, we go for the barium mill X-ray. So, some barium sulphate salt is given to the patient is taking some dilute version of that particular salt, is basically not solution, it is a salt type of thing, because it is insoluble one. So, that salt is there and it gets a very thin layer on your intestine, whether it is a large intestine or small intestine, but is basically that particular deposition of that particular barium sulphate material is detected through X-ray. So, we can find out where you have, that means if you have some cavity, if you have some ulcer, all these things can be detected by your barium sulphate X-ray. We call it as the barium mill we add, and that barium mill give you the barium mill given X-ray thing. So, after barium we just now go to the most important compound industrially based on chromium, because chromium we all know is industrially also very important, because while you go to the iron industry, for the steel industry, chromium is the most important contribution it gives for making you stainless steel. So, how we get chromium? So, is this particular subject will be very interesting to everybody if you try to understand element wise, that if you get these all in a form, that when you get this particular material as element wise in the periodic table, that you have chromium. So, we think of that particular chromium, how that particular chromium is available to us in terms of its ore. So, what is the most common material what will be available for getting chromium, and that particular one through digestion or processing to convert it to some value added compound, which will be industrially very important as well as industrially very useful. So, the economic importance of all these chromates and dichromates are there, which will be very useful, and we can get this from the different chromium sources. We will see what is that chromium source. Then we can make chromic acid, which is CrO3, which is hexavalent chromium. Then basic chromium 3 sulfates we can have, and other chromium 6 compounds. So, both chromium 3 and 6, these are the well known most readily available chromium oxidation states, as we all know, including your starting compound for laboratory use also the chromium trichloride. We know that the chromium is in trivalent state, or the dichromate or chromate, which is in chromium in the hexavalent state. So, both these chromium, whether you have a trivalent chromium or hexavalent chromium, can be obtained through your chromium ore. So, you have the chromium ore, and that chromium ore when you have, you go for the digestion, and the digestion of that particular chromium ore can ultimately give you the product. So, that is your most important compound of chromium, which is your sodium dichromate. So, next we will see how we can make this sodium dichromate from your ore. So, once you get this sodium dichromate, so this industrially important compounds we can very quickly make. So, chromium ore through this digestion is getting to its highest level of oxidized form. That means, your not only the chromate form, it can be converted to the dichromate form. So, once you go to this dichromate form, from that dichromate form, how you quickly go back to your chromic acid form. So, you add concentrated sulfuric acid only. So, addition of concentrated sulfuric acid to the pure and dry product of sodium chromate, dichromate Na2Cr2O7. So, dichromate will be converted to your chromic acid CrO3. So, dimeric form is gone, because the dichromate has a chromium oxygen chromium bond. So, that is gone. So, only you have the chromate unit with you first, and then through the removal of water molecule further, you get the corresponding CrO3. So, this can be utilized. So, chromic acid is very useful in electroplating, not only the steel making component chromium, but also this chromic acid, the hexavalent chromic acid directly we use for plating of some material electrochemically. So, for electroplating. Then from sodium dichromate we go for the basic chromium sulfate. Basic thing, always we know the terminology, we always use industrially also very important terminology. What we use, that when you have some extra hydroxide ion or hydroxide group in the molecular formula. So, that hydroxide bearing chromium is a trivalent one. So, if you have CrOHSO4, that is your basic chromium sulfate. So, that chromium sulfate can be utilized for chrome tanning agents. So, in the tanning industry, for removal of the getting the skin very well, to remove the hair, the skin hairs from the different animal skin, we use this particular material, that means the basic chromium 3 sulfate. So, huge amount of this basic chromium 3 sulfate is consumed in the leather tannery industry. So, the tanning process is dependent on that, and we should also be very much careful, because when the effluent water is coming from the tannery, basically is highly concentrated with the chromium salt, because if we do not able to consume the entire amount of chromium for this particular process. So, in the tanning industry, we should be careful enough to utilize the entire amount of that particular chromium, and we should not leave behind any unreacted chromium or any other form of chromium in your effluent water, or what we are rejecting to the drain water, or ultimately to the river or the sea, which is basically contaminating our corresponding marine life or the aqua life. Then this particular compound, that the sodium dichromate, is also useful through metathetic reaction. That means, you change the corresponding cationic part to potassium as well as ammonia to give you potassium dichromate and ammonium dichromate. These dichromates together with that of your sodium salt. So, all three, sodium, potassium and the ammonium salts of dichromate, are very useful and strong oxidizing agents, starting from our laboratory titrimetric method. We learned from our very old days, from our school level, that potassium dichromate titration, that oxidizing agent for your redox titrations. So, we will take chromite as your ore. So, this chromite is in your hand. So, chromite is nothing but your iron chromium oxide ore. So, its formula is FeCr2O4. So, is a double metal containing ore and which is therefore a spinel type of thing, because we know that the spinel can have a double metal oxide form. So, oxide lattice you have, and you have different sides, one is the tetrahedral sides and another is the octahedral sides. So, due to the occupation of those sides, the tetrahedral sides and the octahedral sides by the bivalent and the trivalent form of those compound, because here chromium is in the trivalent state and iron is the bivalent state. That is why you are balancing the entire 8 negative charges which we are getting from 4 oxygen centers. So, two types of spinel we can have, one is the normal spinel and another is the inverse spinel. But right now we will be only interested to know the spinel structure, and that spinel structure you have to destroy to get chromium out of that compound along with some other metal ion. In case of your chromite ore you have iron, in case of your magnesiochromite you have magnesium. We go for your digestion in presence of sodium carbonate and sufficient amount of air, and air gives you that oxygen. So, your chromite is being digested to give you sodium chromate, and the amount of iron present in it will be converted to your ferric oxide, and carbon dioxide will be liberated to give you the sodium chromate. And this sodium chromate is a sodium salt. So, alkaline oxidative digestion we call, because we have added some alkaline salt as your sodium carbonate salt, and we go for the digestion in presence of excess air or excess oxygen which is coming from your air also, and in solution we get the corresponding sodium chromate. So, Na2CrO4 we are making out of this, and that can be utilized for utilization of this chromite, because this chromite can be useful in steel industry. So, large amount. So, almost 75% of this is utilized for making stainless steel, because it is a very useful material for making stainless steel through incorporation of chromium. Then the refractory material, the tiles, the bricks and all these things can be made through the incorporation of your chromite ore, and lately the remaining amount, that means 13%, can be utilized for chemical industry for making some very useful compound like that of your sodium dichromate. So, you have this thing, how you go for that digestion. So, you take the chromium bearing ore, that chromite ore, you add sodium carbonate and other additives if you try to get it. So, grinding, drying and weighing processes give you the mixture. So, 3 different processes: grinding, drying and weighing. That means how much you are adding and your particular composition, that means the weight ratio is also important. So, mixing gives you, and you go for the digestion, and the digestion is giving you something where you get that after crushing. So, everything is mixed, then you go for the crushing process, and the crushing then you mixed with air, and air give that particular digestion, and then you have the gas what is coming out. So, after crushing basically we go for the stirring and stirring and stirring. So, then we go for addition of sulfuric acid. So, the sulfuric acid process or the sulfuric acid path for acidification, and then the process of acidification followed by centrifugation, and centrifugation gives you the corresponding development of the sodium dichromate formation. So, addition of your chromite ore, sodium carbonate, air, that is digestion, and everything will giving you the corresponding sodium dichromate liquor. And at the same time what you are producing, the gas basically from the digestion step, gas is going out, and gas purification chamber should be there, and that can take out the gas for storing and further utilization. Then we can go for the concentrated form of that liquor and giving you the sodium dichromate crystals through crystallization. So, either you have some very concentrated liquor form in the liquid form, or you go for concentrated one, and once you exceed the supersaturation level you think that you can go for crystallization, and the crystallized form still you have the trapped water molecule, is not a dry one, is a wet one. So, you can go for the drying process. So, after that drying process you get in your hand the sodium dichromate crystals. So, we get basically the sodium dichromate in the dihydrate form, because what we get, what we use in the laboratory also, it is the anhydrous form, no water of crystallization. So, but in the crystallized form what we get in the water medium is your corresponding process, what you get is as your sodium dichromate. So, that sodium dichromate is in dihydrate form. It is a simple process, but it has sodium sulphate as the byproduct. So, when you react with sulphuric acid, obviously the sulphate will come out as your sodium sulphate from the material. So, you have to take care of that particular amount of sodium sulphate what is being formed over there. So, that sodium sulphate should be taken out. Now, the sodium chromate can also be digested in some other way that I already told you, that you can go for carbon dioxide also. So, these are the very simple processes what you require basically to add, whether you are able to add sodium salt of your chromate to your sulphuric acid, or you directly treat with carbon dioxide as a gas molecule, converting that in both the two cases to dichromate, because you require this thing, because in both the two cases you require the acidic medium, because the chromates we know can follow the dimer formation, the condensation of two chromate units to give you the dichromate, which is catalyzed by protons, the H plus. So, this H plus can come from sulphuric acid, or that H plus can come also the mixture of carbon dioxide and water, which is nothing but your carbonic acid. When we get a mixture of carbon dioxide and water, we know that this is your carbonic acid. So, that carbonic acid through the removal of bicarbonate anion also gives you the proton. So, that proton is still available for converting your chromate to dichromate. So, is a basically a reaction which is driven by proton. So, this second process can be considered as a complicated process, but no difficulty in utilizing the byproduct, because sodium bicarbonate can be very easily utilized. The chromate containing bicarbonate what is available, you can separate it out, and that separation of that bicarbonate can gives you a huge amount of sodium bicarbonate formation, because double of the amount what we get as sodium dichromate is formed as a sodium bicarbonate, and that bicarbonate when heated at 200 to 300 degrees centigrade giving you sodium carbonate. Then we see how we see the get the chromic acid, and that chromic acid preparation is a simple one from the other case that you get, that means the removal of this thing, that means chromium as in only oxide. So, it is a metallic oxide like MO3. So, that metallic oxide can be obtained again by the use of sulphuric acid. So, this can be utilized as a chromium hexavalent oxide, and the chromium 3 oxide can be prepared from sodium dichromate with the reduction of charcoal, and that charcoal or sulfur or ammonium salts basically. So, you have the dichromate directly, then once again the dichromate when gives you chromic acid, it can also give you the chromium in the trivalent state, which are Cr2O3, either by the use of carbon reduction or by the use of sulfur reduction or ammonium chloride. So, ammonium chloride you have the corresponding ammonium chloride. So, ammonium chloride, that ammonia basically, ammonia we all know is also a very good reducing agent. So, that ammonia of ammonium chloride can also be utilized for making of your chromium 3 oxide, that means Cr2O3. So, when dichromate is being burnt in presence of your ammonium chloride, we get this reaction, and the same reaction we know from our school days again, that if you burn ammonium dichromate, the same reaction can take place. So, this basically gives us some idea that how we utilize the different chemical reactions, the inorganic chemical reactions for the productions of all these things. So, up to this point, that means the formation of these chromium compounds, the chromium 3 oxide has a low sulfur content for this particular process, because we have not utilized sulfur, can be used for the aluminothermic manufacture of chromium metal. So, this can be utilized further for the production of chromium metal also. So, this can be very useful starting material, these oxides. So, oxides if we are not able to get as the ore material, that means the chromium, that is chromous oxide, the chromium in the trivalent state Cr2O3, we can convert it to some other form and get it in a readily available form to the production of chromium metal, which has a very high demand in the industrial sector, for the steel industry, for any other industry. Okay. Thank you very much.